Hey everybody, Mrs. Schultz here. I told you I would do a quick little review here for physics as we get ready for our unit test. I took a look at that unit test, prepared kind of a general list. Of course, we let you guys know the need to knows, and like I said, we're going to try and break away from some using those as much as we go through, but I figured it would be a good opportunity to just kind of go over a couple of concepts with you guys before we get started. I am recording this since I know most of you got out early today and so aren't able to meet with me, which is fine. But at least this way you guys can take a look at the recording and we can work with it that way. Let me pull up a whiteboard here, just a second. Hold on, I'm not super fast at this. Sorry about that. All right, what we'll do, I will pull up a document and we'll do it that way. As you know from your need to knows, there are just a few concepts that are going to be covered on this. It is not as lengthy a quiz as you're going to have later on because obviously this unit is a little bit shorter and therefore, oh, here we go, perfect. Therefore, it's going to be a little bit of a shorter quiz. The big main areas that we're going to need to focus on are lots and lots of stuff about precision and accuracy and telling the difference between the two. A little bit about metric, which all of you should be familiar with by this point, although if you do need a quick review on metric, please give me a call and we can go over that. A tiny bit on significant digits, which we're going to get into way more in the next unit as we begin to use them, and that you should actually remember from your chemistry class. And then a tiny bit about speed or graph reading in general, a little bit about speed, a little bit about velocity, but mostly about reading graphs. And most of you are fairly competent at reading graphs, and that's another skill that as we go through the units, we're going to build on more and more and more. So I want to give you a quick analogy about precision and accuracy that you've probably seen before, but just want to use as an example that I think you might find helpful. One of the best discussions I've ever heard of precision and accuracy has to do actually with this idea of darts. So my sad little dartboards here. There we go. All right, obviously we know that the point of darts is to get your dart into the bullseye here at the center. However, that doesn't always happen. So you can have an illustration of precision and accuracy this way. You can be precise, which means that if you were to shoot a bunch of darts, you could get a grouping like this, all grouped together at the edge. This is considered to be precise, right there. Oh, interesting. Accuracy, on the other hand, is where we would have, oops, sorry about that. Didn't mean to do that. Nope, I lost my marker. Give me just a second here. Lost my marker. Give me just a second here. Sorry about this. accuracy can look like this, where if we throw a bunch of darts and we get very, very close to our bullseye, but we don't actually hit it. All right, obviously when playing darts, what we're looking for is we're looking for a combination of accuracy and precision by having a very nice tight grouping, but all within the target range. Obviously in science, that's what we're looking for as well. We're looking for a combination of accuracy and precision together to produce the best results. It does not do us any good to be very, very accurate if we don't have predictable results, nor does it do us very much good if we can get very predictable results, but they're not close to the correct answer that we're looking for or to an accurate answer of what's actually happening. When this occurs within a scientific experiment, what that usually means is that we've got some kind of problem with the way that our lab is structured, so that we're not getting accurate. We're not actually testing the variable that we think we're testing. If we can get accurate results that are not predictable, that's a problem with us and how we're performing the lab generally. So that becomes then an issue where you need to look at what is my scientific method and how well am I controlling the variables and how accurately am I measuring. And this is where significant digits really comes into it, which we'll talk about more going forward. In an ideal circumstance where you have a well-controlled experiment that's actually only experimenting one variable, only testing one variable, and you have your controls under control, and you're accurately measuring, you should be able to yield both an accurate and a precise number. It may not be accurate and precise based on what you thought it was going to be. That's a different problem, but it will be accurate and precise to what's actually happening. So the rest of the test is pretty straightforward and pretty easy to understand. So I would encourage you just to go back through, look over your notes, make sure that you review your scientific method, you review your metric system, go back and do some practice on precision and accuracy, and you should be all set to go. So I hope this was helpful for you guys. Like I said, we're going to try and build skills going forward on how to actually study. I'm going to really get into that next unit where we really start talking about content and really getting into kind of the meat of the course and how do we then go about using our course and using our information to help guide us in our preparation for assessments. All right, well, you guys have a great day, and let me know if you have any questions. I'm here to help you. Bye-bye.